Here we go. So I'm going to show how to solve this problem. What I learned by solving this problem too, I'll go over what I learned at the end, but I feel like I learned some useful things to really take note of for any future algorithm problems. So the problem is called Decrypt message, and it has a very long text, but I will try to explain it without using all this text. So a couple of things. The major goal is basically to take this example. Basically shows what you're doing. You're taking you want to decrypt a word. So you take a message like this, right? This is an encrypted message, DNOTQ. You convert it to the ASCII values, and then, well, it's kind of weird. It's kind of hard to see how you get to this second step, actually. And how they explain it how you go from the decrypt to the encrypt. So I'm going to explain it in that terms. We're going to have to do like some reverse engineering to really go backwards. So the decrypt message, you start with like crime, right? You want to make an encrypted version of this message. You start with the ASCII values for each one. For the first one, you start with ASCII value, you add 1 to it, and then you return that value. For the second value, you take the 114 and you add the previous value from the previous second step, which is 100, so you get 214. And then basically, you can't return 214 because it's not in the range, so you basically kind of like subtract 26 until you get it in the range between 97 and 122 in Python. And then same thing here, so you go to I, you add the previous value to the 105, you have 214, you have 319, so on and so on and so on. That's the basic thing. So that's how you go from a message that's already decrypted to the encryption version of it. But the problem actually wants you to decrypt it, which means you want to go from the already encrypted message to the decrypted version. So we'll get started. We only have lowercase letters. That's important to note for the ASCII values. But really, we're going to use some Python functions in it to do this. So the approach is one. So we're going to reverse engineer. So what I mean is, first, encrypt first. That's what I'm going to do. I'm going to encrypt first. I'm going to actually come over here and create a function, encrypt word. This will actually make it easier by encrypting it, because it's easier to encrypt than understand the decrypt. So if I do the encrypt first, I can go through the process. So you basically convert. I'll go through the process and I'll number this. So you take the first letter, you convert the ASCII character to the ASCII value, and this is what you do for the first letter. So this is also sort of the first character in the word. And then what you do is you add 1 to the ASCII value, 3. I would say you subtract 26 until it is less than 122, you know. So this is like a while loop. 4. I mean, you might not have to do that, right? For the first one, you don't have to do that for sure. So actually, well, no, you do have to do it, because what if the ASCII value was 122? You add 1 to the 122, now you're 123. You need to subtract 26. So okay, yeah. So yeah, consider if the first character was Z and ASCII value equals 122. You add 1, you get 123, right? And now you need to subtract the 26. 4 is I think that's it. So then you just want to convert the ASCII value to the ASCII character. Right, so that's for the first guy. And then the second, let's say characters after the first, we want to convert the ASCII character to the ASCII value. We always want to do that. But we want to add the previous one. We're going to add the second step prev value to the ASCII value. Okay? Right, so that's all I'm going to do. So if I take the second step previous value, the second step previous value for this problem is 100. So I take the 100 plus the 114 and get 214. Then I would want to subtract until basically until it, so then you subtract 26 until it is in the range. I'm going to write it like this, between A and Z ASCII values. Okay. 4 is then I want to convert. It's the same as before. Same as before. We keep doing this, right? So this is how I can encrypt it. So encrypting sounds like, oh, let's do it. Like I already have a good idea. So I'm gonna create what I need. N equals length of words. So I don't have to do this. For I in the range of n, we want to take, I do want to set something. So I want to set second step prev equals 1. So I'm going to initialize that as 1. So the first, okay, let's remember what we're doing. So we're trying to get the ASCII. Well, this is how I think about this is you're getting the ASCII value for the decrypted. So, well, you want to find the encrypted, right? So you want to find the encrypted. Let's just say the encrypted will be basically, alright, the encrypted ASCII, or the encrypted val, is basically going to be decrypted val plus second step prev, right? So like it's 1 initially, and then what we want to do is we want to do 1 of this is, like I said, while it's greater than 122. There's also a way to, so while it's greater than 122, we will basically, what I want to decrement it, right? Decrement by 26. Oops. And then the other thing that I can do is basically update my second step prev, prev by doing plus or equal to. And what I would put here is I want to take the, what's it called? I want to take the current encrypted value and add that to it. So like my current encrypted value looks like it's 110 maybe. Oh wait, no, that's not right. That's not right. You want to take the decrypted value. That's right. You want to take the decrypted value, add it to the previous one. So take the decrypted value. So that'll update my second step prev. So I update my second step prev. I just need to like add this to my result. So let's generate some result. Empty string, and whoops. Okay, and then we can always do add to this the character associated with the encoded val, and then at the end we want to return this rest. So this is awesome. This is basically to encrypt it. It was very easy to kind of work through the encryption of this problem, and then be able to get the code down. Now the thing that we can do, the thing that I can do here is I can basically basically what I can do here is I'm thinking is, oh, I was just on my train of thought. Whoa, oh crap, oh crap, oh crap. What was I doing? So okay, yeah. So what I'm gonna do is I feel like so something's missing. So right, so like you can imagine this value is gonna be very large. Like at the end it's gonna be 428 plus the decrypted value, which might be like 109. So that's like really high, right? That's like 537 or something. So 537, then you have to subtract 26 a lot of times. But we don't have to do that. So there's kind of like a trick here where basically when you add the second step previous, you're adding a bunch of 26s, right? You're adding this 26 plus 26 plus 26 plus 26. So I'm going to try to demonstrate this here. So like, let's say second step prev equals, we'll start with 100, right? And a decrypted value equal to 114, right? So we're like, okay, convert this, do 114 plus 100, we get 214. Then we're going to have to subtract 26 about 4 times, I think, my guess. But you could just do this. The 100 doesn't matter, right? The 100 is basically, if you take the remainder, it's like 26 times 3 plus the remainder, which is 22, I think. I'll check. 26 times 3 plus 22. Yeah. So that's what it's like, right? This 26 times 3 doesn't matter, right? Like this 26 times 3, I was going to have to like subtract that 26 times 3 times. But what really matters is this 22. So if you add just the 22, which is the modulus of this with some 26. Also, let me make sure this, yeah, so this will work with the 1. Right, okay, so then, so then once I get this done here, then this will work, and it looks kind of useful, but it gets really helpful when you look at step previous equals, like, go to the 428, right? What is 428? 428 divided by 26. Oops, divided by 26. 16. So this is going to be 16 times 26 plus whatever the remainder is. The modulus of this. Like this, so 12, right? Plus 12. Those 26s we don't really care about, because here we're going to be calculating NK val, and that'll be equal to 101 plus 16 times 26 plus 12. We're just going to have to subtract all the 26 off, because it goes way far outside the ASCII range. So we just really need that 12. Now all I need to consider are edge cases. So what if we have NK val equals 97, right? The lowest value you can have. Then what if we add, the highest value we can add to is 25, right? Which would be in range. Anything we add to will be in range. Okay, what if we have the 122 plus 12? So we need to subtract. So we still need to subtract 26, but we only need to subtract it once, which is way better than subtracting, I don't know, 16 times or whatever. So introducing this is going to make this way more optimized, in a sense, if the word gets really large, right? Okay, so now I've encrypted, which is going to be super useful. Now to decrypt, we just kind of have to like work backwards, in a sense. So let's try that, working backwards. So n equals length of word. Second step, prev equals 1. I'm just laying out some of the bases. I know I'm going to need this already, and I'm going to know I'm going to do this. I know that I'm going to be computing the dec val. So now I just need to work out the logic for it. So decrypt. So this is a decrypt part. So for decrypt, basically we do the same thing. So we convert the ASCII to the thing, to subtract 1 from ASCII value. And then now that we're subtracting 1, our etch is going to be different. And oh boy, this will not be subtract, this will be add now. So I'll get add this, and then I'll go to 4, and then 4 would just be this. Oop, I just basically did the whole thing. So that's for the first character, right? First character. Then if we do second and after, it's going to be very similar to this, so I'll just copy this, paste it. I'm going to convert it, you're going to add the second prev. Well, no, we're not going to add, we're going to subtract now, right? Because we're going in the other direction. So like, when I get go to 110, I want to subtract 100, and then add to it until I get to 214. So I'm just going in a different direction. So instead of adding second step brief, we subtract second step brief, and instead of subtracting 26, we add 26. Everything else kind of stays the same. So let's check this out. So we take decval, it'll be equal to the encrypted value that we're given minus prev, and we can still use the 26 technique, and then while decval, so it could be less than, so while decval is less than 97, we would do decval plus or equal to 26, and then and then we want to update second step prev what? Wait, how do you update second step prev? I think it's going to be decval. So yeah, so we still update second step prev the same way. And then res plus or equal to the character of decval, because what we care about with decrypting, and return res. Okay, so the cool thing about this is that once I figured out how to encrypt, decrypting was super easy here. And then I just need to test this, so we can do decrypt this word, right? Run code. What? Oh. Wait, what? Why did I do this? Oh, okay, yeah. Oh, I forgot. Decrypt val is equal to the word at I. Encrypt val is equal to the word at I. That's right. Okay, run code. Right. I don't know why I'm messing this up. Like, this is basically the most important part of it, is converting it to the ASCII value. So convert it to the ASCII value here. And then, so okay, yeah, so I convert to ASCII value. Everything is in terms of value, then you convert back to character. Okay, now run. Okay, so that works. And if we try this word, if I can get it. Boom, and I can run the code. Alright, encyclopedia. Now, okay, that's fun. And then check this out. Encrypt. Now I can encrypt the word and then decrypt it, which doesn't really make sense, but yeah, you get crime back. So you encrypt it and you decrypt it. And I could do like anything. You do FBI, which is in this. And I should get FBI back. And I do. Run the tests, and yeah, they all pass. So yeah, this is a cool problem. So I did want to go over what I learned from doing this. So yeah, I didn't do too well at this at first, but I suppose that's part of the learning process. But like the main thing I had trouble with is I spent so much time trying to figure out the decrypt. So much time trying to figure out the decrypt. When in reality, reverse engineering this, which it actually kind of tells you to do that, but I just had trouble doing it for some reason. Like figuring out how to encrypt this message is much easier, and this modulus 26 is a little tricky to understand at first, but you don't really need that. You could ignore that and it'll still work, which is what I did at first. But yeah, so encrypting it first really helps out because you can really just follow along with how this is done, and then decrypting is really just changing, going in the reverse direction, going the addition here and going the subtraction here.